There you go. Okay, so 1.09 to the power 16. So it will be 3.97 times 200. So it will be 794.06. I think we can keep up to this. Okay, is there anyone who has a different result using his or her calculator? Any different result other than this?
Now we would have to add some, move the decimal, right? Because we are using 200,000 as our number.
Oh no, so the rounding part is later on. So my
Oh,
question is, has everyone reached this, uh, whatever the value is in decimals? My question is, has anyone a different result other than this using his or her calculator?
that's what I got.
Anyone else has a different result? This is
No, that's what I got.
okay, because this is really um, easy to have a different result. If you just plug in a wrong way, um, your calculator will give you a wrong result. I mean, a different result by all means. So that's why I try to check whether you have the same answer or not. Okay, so now we have a population to calculate, right? And it's in 200,000, sorry, it's in thousands rather, not 200,000. So it's in thousands. So what can we do to make this look better? Because this is in decimal, and we don't really want to have a population decimals. We want to have whole numbers, right? What should we do now? What's the suggestions on this? So first of all, it's in thousands, right? So technically, it's 794.06. So as Ashton said, as we are calculating in thousands, let's just have one more decimal here after this decimal point, one more value rather, simply because we'll multiply it by 1,000, right? So the next value was 1. So let's just add one more value. It was this. So I'll do that. And after the decimal, it has 1.17. So you can avoid it now. You can add one or two more values after the decimal to cross check. Sorry, I wrote 2, it should be 7. So this is up to 5 decimal points. So you can see if we multiply it by 1,000, we reach to this population, and after the decimal, it's less than half, right? So we can say that the population will be 794,061. We try to round it to the closest or the nearest whole number, so we can clearly write this. Okay, any question up to this? Then we can move forward. Any question? All good? Okay. Now, if somehow your answer box, I mean, when you are doing it in MyOpenMath, let's say, have a box like this for a solution, and later they have the unit in thousand. Now what would you do? Would you still write this, or would you write something different?
No, then you just put 794.
Very good. Can you see why, everyone? Is there anyone who has confusions about it? So it's really important to see the entire question first, whether or not it gives you the freedom to express it at your will. I mean, if the unit is given in thousands, and if you still write this, you'll be penalized. Can you see that? So it's really important to see what the question actually wants you to do. It may have a format like this, where in the question they will mention that what will be the population of, let's say, for example, in Tacoma, uh, in thousands. They might have it in the question as well. It doesn't necessarily mean that they need to have it here with the answer box. They might have it in the question. So it's really important. It's really, really important to see the entire question first. Whether it asks you to write it in thousands, it may even say write it in millions, right? So you need to check which unit they want you to write uh, for the particular problem. Okay, so just be careful about that, because you don't want to get yourself penalized just because you missed the unit. You just um, overlooked it. So, okay, so that's C, by the way, and we want to go to D if you don't have any question. Anyone? Any question at all? Okay, let's move on then. D says, when does this model predict Tacoma's population to exceed 400,000? Now you can see the question itself says the population has to be 400,000, right? That's what I was talking about. The question might have it for you, okay, in units. Or it could say, when the population will be 0.4 million. It's technically the same thing, but you need to be careful when you calculate, um, plugging in the values and all that. Okay, when you transform these units from one to other. Okay, so now what does it want us to do? So we know P of n is 1.09 to the n times 200,000. And it says our population will be 400,000, and it wants us to find when will it uh, exceed that. Okay, what should you do? Can you eyeball the question and see what should you do next?
Would you make it equal to 400?
What equals to 400?
The 1.09 to the n times 200,000.
And what made you think that?
Because P of n is the population.
Exactly. Again, understanding what's going on is really, really important, because if you don't understand that this will be our PN for this problem, then you will walk into the wrong direction, right? So now this is the population, so it will be 400. 1.09 is fixed for this. N, we don't know it, and 200,000 is fixed as well. So we are trying to calculate the N here. Can you see that? And even you can eyeball it from the question. It says, when will it? This when definitely means time, right? Okay. And now we want to solve it. Next, I'll not solve it now. One by one, you will say, and I'll just copy your command. What should I do next? I want you guys to solve it.
Would you divide both sides by 200?
And why?
Because you want to try and start getting n by itself.
Very good. So we'll try to isolate this term with n first. Eventually, we'll try to isolate the n completely, but the first job is to isolate the term with n. That means we'll try to isolate this green parabolic portion. It's not a circle, so yeah, it's a parabolic portion. So we want to isolate this 1.09 to the n because it has the unknown value, unknown variable rather, n, which we want to calculate eventually. So if we want to isolate this, we need to get rid of everything else associated with that term. So we have a 200 here as a product with this. So if we want to get rid of this, we can divide both sides by this, which is 200. So let's divide it. So it will be 200, 2 rather. 2 equals to 1.09 to the n. I've just divided both sides by 200, okay? All right, so what's next? I can actually rewrite it on my left. So this technically is the same thing. We can do that. Now what's next? What should you do to calculate n, to isolate n?
I think I know, but I'm not completely sure.
Just go for it, no worries.
Would you take the log on each side?
And why?
Because you have an exponent, a number with an exponent equal to a whole number.
Very good. That's it. That's it. Yeah. So we know a very good property of log, which is if you have log x to the n, we can rewrite it as n log x. That means the power, the exponent comes in front. So we can definitely relate this to this known property. So if we take log on both sides, log 1.09 to the n log 2. Obviously, whatever we do, we need to do that on both sides. Now, using the same, using this very property, we know this n will come in front and we'll have log 1.09. Any question up to this? We have used this property. Sorry. Any question from this? All good? Just a quick reminder, if you write it in the chat section, when I'm writing, I may not be able to see that. So, and obviously when it will pop up, if I somehow miss it, I won't be able to see unless I check the chat box again. So if you see that you have a chat, but I am not responding, that means I might have missed it because I'm looking at the on the screen of the iPad. So it's difficult to check both screens at the same time. So if you feel you can unmute and say if you have any question, okay? All right, okay. So we have used that property. What should we do next?
You should divide both sides by log of 1.09.
And why again?
To isolate n on the one side.
Very good. So again, we'll actually use the same principle, what we have done here. We tried to isolate the term with n. Now, finally, we will be able to isolate the n completely. So for that, once again, we'll try to get rid of everything else. So we'll divide both sides by log of 1.09. So on our left, we'll have n, and on our right, we'll have log of 1.09. Okay. And now again, you can use your calculator and check what it gives you. So log of 2 will be 0.30103 divided by log of 1.09. So I guess it will give 8.04. Let's say, let's take 2 more digits, 32. Yeah. Okay, is there anyone who has a different value? If you use a calculator, you should get this. I might have a wrong value, so you don't need to agree with me each time. If you have a different value, you can say. Everyone has the same value?
Yes.
Okay, cool. So we have calculated n, but we are not yet done. We are almost there, but not quite. So the next thing, and hopefully the last thing we want to see, is how can we represent this or rephrase it rather using English words in accordance to our question. So our question says, when will it exceed that 400,000? So approximately after 8 years, it will what? Wait a minute. Okay, we had a higher value. Okay, I was slightly confused. Why did he get 8 years? Because we have already calculated for 16 years. Okay, we have a higher value. Okay, that makes sense because it's actually 794,000. So it's more than 400,000. Anyway, yeah. So we should get less than 16. Yeah, that makes sense. Because after 16 years, it will be about 794,000, right? We have already calculated it here. Yeah. Okay, so just about 8 years after, it will become 400,000. So we'll say that after 8 years, it will exceed it. Okay. So that's just the approximation. Okay. Or you might say on the 9th year. That works as well, because it's just slightly more than 8. So you can definitely say that. Okay, any question from this? This exercise 7, I mean the problem 7, is a really, really ideal example of what the question will look like in your exam. It's one of the finest examples from this topic because it covers everything. In A, it says you to find the recursive form. In B, it says you to find the explicit form. In C, the time duration is given and we'll calculate the population. And in D, it's vice versa. The population is given and we'll try, we have already rather, found the time it will take rather to reach that population. So it has everything, it has literally everything you need to know up to this. I mean, we will learn one more topic in this growth model, which is logistic growth. But up to this, I mean, the exponential growth, this question has everything. So this is really a very good question. Any question from this entire problem, starting from A, B, C, D, any question. No question at all? Okay, how's the homework going, by the way? Has anyone started it?
Yeah, it was pretty simple.
Yeah, I'm trying to do that, to be honest. I can definitely set up the question really, really hard, but that doesn't really make sense. So I try to keep it simple so that if you just understand what we have done in the class, oops, sorry, uh, the screen sharing is uh, has opted out from Zoom. Just give me a second until I come back. So yeah, I'm sharing my screen again. Okay. Okay, yeah, here we are. Yeah, so I try to keep it really, really simple, and I'll keep doing that. So if you just understand what we have done in the class, what we have discussed, I guess everyone, like the second exam, at least half of you got full credit. So that's a really good sign. Hopefully the number will increase in the next one. Okay, so what should we do next? We have completed example 7. We'll not do logistic growth this week because it will take some time. It will require you to learn some new definitions. So next week, before we meet rather, I want you guys to know the definition of carrying capacity. That's a pre-class assignment, so that when I say this word, it makes sense to you. You can understand what does this mean. Pardon my bad handwriting. If you don't understand, just raise your hand. Oops, sorry. Okay. Okay. So I want you guys to know this definition. And of course, I'll post an announcement with probably a question from the exercise. I need to check which one should I give you. So I'll make an announcement. So apart from the homework, you'll have a pre-class assignment as well. From the exercise, I'll give you a question which you need to solve before we meet next time on Monday. Okay. So let's just do a short problem because we have only 10 minutes. Let's see what we can do. Okay. 7. Sample 15. Sample. We have already done it. Try it now 4, I believe. Okay. We've done example 14. looks like we've covered almost everything up to logistic growth. That's a very good thing. Okay, let me give you a really quick question which you can solve now and show it to me. Okay, so let's solve it. I want you to solve it for me. Um, let's do it. Okay. Excuse me. Okay, can you find the value for me? So it would be log of 1/1000. You can solve it now and show me your work. I mean, you can write the solution in the chat section. You can send me the picture of it. And or if you have any question how to do that, we can discuss it. I'll check everyone's work. And you have 3 minutes for it. So let's start. There is no exercise number of it. I've just made it right now. Okay, I can see some answers in my chat. I only have 2. You are 14 in total, so I expect 12 more. Is there anyone who has confusion how to do that? Because it looks kind of clumsy. But if you just transform it, if you just rewrite it, okay, I can see one answer. Not sure if this is correct. So that means we can actually discuss it so that it makes sense. Okay, I'm a little bit confused. Okay, I don't have my calculator right now. You don't need calculator for this. You don't need your calculator. That's why I am repeating myself that if you have just, even though if you have a little confusion, we can rediscuss this. So let me wait for a minute uh, and rediscuss how can we do that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need 4 more answers. If you can't do that, you can definitely say, I can't do that, but you need to give me the answer. I need 4 more. Who are the other 4? It's difficult to cross-check though. Let me see. Okay, I have one more, 2 more. Okay, so 12 out of 14. Okay, so I want you to solve log 1/1000. Can you do that? Can you tell me the answer? You can't really use your calculator. You don't, to be honest. I shouldn't say you can't. You definitely can use your calculator, but you should not use your calculator for this. You can easily solve it by your hand. Okay, I guess I have all 14 answers. That's very good. That's what I wanted to. Would you multiply by 1000 to get rid of the denominator? Okay, so that's a good question. That's a very good question. I'm glad that you asked. So, okay, let me show how can I do that. Okay, hopefully it will make your doubts clear, and hopefully it will make more sense. Okay, so the first question would be whether we'll multiply by 1,000 to get rid of the denominator. Okay, so that can only happen when you have an equation. I mean, when you have two sides, you can divide both sides by 1,000, or you can multiply both sides by something to get rid of a certain value. But we don't have an equation, we have an expression rather. We can't really divide anything by 1,000 by anything, right? When you have an expression, you can't really divide anything, divide that expression or multiply that expression by anything. And secondly, the key point, even though it was an equation, we wouldn't be allowed to divide by 1,000 here, because this log is working on this. So if we divide by 1,000, it will divide the entire amount, or rather multiply. Okay, if we just multiply, let's do it this way. If we multiply both sides by 1,000, it will actually be a product of this entire value. It will not cancel this 1,000. You can't really do that, because this is log of something. That means this is an operation working on that 1/1,000. So even though it was an equation and we multiplied both sides by 1,000, it wouldn't have canceled this 1,000. Is the question, is the method clear? Okay, very good. Next, we want to rewrite it so that we can use the logarithmic property. So how can we rewrite it? So log 1/1,000 can be written as log 1/10 cubed, because if you multiply 10 3 times, you'll get 1,000, right? So you can definitely rewrite this 1,000 as 10 cubed. So that's one property we have used here. The next property we want to use is to write the reciprocal of it. So if we write this way, the exponent will have the opposite sign. So for this, we have used this property. If we take the reciprocal of it, the order will have the different exponent, I mean the different sign. And now this exponent will come in front. I'll just take 30 seconds more, bear with me, because we can use this from the property of log of x to the n is n log of x. That's another property. And we know log of 10 is 1. So that's the last property we want to use. We can see we have used 4 properties here. So the answer should be -3. Any question from this? Okay, then I'll stop it here today. And on Monday, you'll have one pre-class assignment. I'll make an announcement of it. And hopefully we'll discuss more on logistic growth. Okay. Okay, I'll see you on Monday. Have a great weekend.
Thank you.